All right, welcome Huskies. It's time for us to start a new section, and that section's going to be specifically about unit number 4, and it's going to be all about triangles, okay? Now, it happens that this particular unit that you guys are headed into happens to be kind of a cornerstone of geometry. It's been around as long as I've ever been teaching this, like 20 plus years. And it never really ends up changing, but it does end up working into several other units that we talk about later. So if you're going to get anything out of any one of these units, this one's definitely a go-to. It's got a lot of good stuff inside of it, and you want to get as much out of it as you possibly can. Okay? Now, not wasting any time, we're going to start right off about something about the angles about triangles. And as we well know, we know the reason why it's called a triangle. Tri means the word 3, and we've got 3 angles. That's why it's called a triangle. All right? Now, one of the cool things about a triangle happens to be its number one characteristic, and we're going to put a big old star here, is what's referred to as the Triangle Sum Theorem. So if you were looking at any given triangle that you were taking a look at, say like down here below, you would look at the inside angles of every one of this triangle right here, all 3 of them, and it turns out that if you took all of those particular angles and you summed it up, regardless of what kind of triangle you make, even if it's an obtuse one like that, and you sum up all those individual angles, the sum of the measures of the interior angles of a triangle is 180 degrees. Look at there. It's the magic number. It keeps coming back and showing its face. So 180 no matter what. So we're basically saying that angle A plus angle B plus angle C always will turn out to be 180 degrees, regardless of what kind of triangle you're talking about. Now, that's a really easy formula that we can kind of use. Let's talk about it over here in this question or diagram where we're talking about all these soccer players. Now, I know your guys' might be a little bit dark in terms of the copies and everything. This guy right here is a 20-degree angle, and this one says angle 3. We'll put angle 3 right there, and that says 78 degrees. Now, I'm just talking about the upper one, and it's basically asking you, could you come up with the size of the angle for each one of these given triangles that's inside there? Well, they all make a triangle, and they should sum up to 180. So this angle 3 one up here should be 20 plus 78 plus angle 3 should add up to 180 degrees. And if you wanted to just solve for any specific angle size, you would just subtract the values onto the other side. Now, if I just end up moving these guys over here by subtraction, let's see what kind of number we end up getting from Donna. Donna is my calculator's name. She'll love her. So we'll subtract 20 from 1, and we'll subtract 78 from 180, and we'll get that angle 3 is 82 degrees. There you go. That's how big that one is, okay? So relatively easy concept. Now, I'm going to use the one that's right below that one, too, as well. They say that this angle 61, this is angle 1, and this is angle 2. Now, some things that you could draw from that is that angle 2, since it's on the other side of this particular angle, it is a vertical angle. That would make that one 78. And that triangle down below with those soccer players has to add up to 182 as well. So we'd get 78 added to 61 plus angle 1 would add up to 180. And if I subtract those on the other side, let's go back to Donna and see what she says. 180 minus 78 minus 61 would be a total of 41 degrees for angle 1. All right? So remember, your goal here is to try and get your triangle to be 180 degrees. Now I'm going to zoom in on a little of these. Okay? Find the measure of each numbered angle that would be inside here. Now I'm going to do the same kind of idea as I did before. If I've got a triangle like this one right here, that triangle would have to add up to 180 degrees. So I'd get 57 added to 71 plus angle 2. That would have to add up to 180 degrees. Little subtraction going on that one. Let's try that out. 180 minus this 57 minus the 71. and I'd end up with angle 2 to be 52 degrees. Okay, pretty straightforward concept, nothing really super exciting. Now, the one thing I want to point out in these is not only is it the little triangles that would have to add up to 180, but so does, and I'm really emphasize this bigger triangle right here. So any triangle that you could draw would have to add up to 180 degrees. So maybe finding this angle over here in this corner for angle 3 might entail using that 52 that I've got right there added to the entire angle up here for angle K, which is a 28 and a 71, and that added to angle 3 would add up to 180 degrees. And you would see that you can do just the smaller ones, or you could even do the larger ones. Now, if I subtract all those, what am I going to end up with this one? 180 minus the 52 minus the 28 and minus the 71, I would get an angle of angle 3 to turn out to be 29 degrees, okay? Now, I've done some of those that are in this right here. I'm going to pause the video for a second. You want to try 4, 5, 6, 7, 8, and 9 all together, and you should be able to get the answer for those. All right, and the answers that I came up with for 4 through 9 happen to be the following, and I just kind of highlight the ways I did it. I went probably for angle 7 first, did this triangle right here that happened to be adding up to 180, so got that guy first. Then I did the vertical, which was number 5, so those two ended up matching each other. Once I got that, I could go for the angle 4 over here in this corner, which was 56. And I could do the supplementary one to get angle 6, which was 123. And then to get these two angles, since they matched each other, I would know that that triangle was 180 minus the 123, and then took that answer and cut it in half for the 28 and a halves. Okay? If you need to go back and watch that again, just go ahead and watch that. Now, down here to the bottom corner, it also turns out that another good rule that you can use in triangles happens to be what's called the exterior angle theorem too as well. Now, the exterior angle concept is basically the idea that if you draw any triangle that you stay right here, and then you extend one of the sides further than it needs to be. Now, you could do this on any one of the 3 corners. You would get an angle that's on the outside out here. This is referred to as an exterior angle. Makes sense because it's on the outside. It turns out that the exterior angle, triangle can have 3 exterior angles, have an exterior angle formed by one side of a triangle and an extension of the adjacent side. Each exterior angle has 2 remote interiors. I'm going to put here remote interiors that don't touch that one. Now, here's what they're saying. If this guy is the exterior angle, there happens to be 2 angles that are away from it that don't touch that particular exterior angle in any way, shape, or form. These are referred to as the remote interiors. Okay? These are called the remote interiors. And they're just meaning that they're remotely away from the exterior angle. Now, it turns out something funky actually happens here. It's a pretty cool little deal. That if you could tear off these remote interior angles and you could rip them off the triangle, which is kind of violent, and you pasted the inside right here where the interior angle is, like you put one tear like that and the other tear like this on there, they turn out to be exactly the same size as the exterior angle. So the rule here is that the exterior angle is equal to the sum of the 2 remote interiors. So in this particular case, angle 1, this guy on the outside, would be equal to angle A, the one guy away from it, added to angle B, the other one that's away from it. This is called the exterior angle theorem. And it's basically a reasoning behind it is because of the triangle sum deal. It works out that way. So let's see if we could find some of these measured angles that are going on here. Now there's a yoga gal up here. I love the little yoga gal. Here we go. She's doing yoga. I don't know what pose that is. If you're taking yoga, you could probably tell me. It says JKL is the one that we're looking for. JKL. Now, that's this angle way out here on the outside. Now, I probably covered up things I shouldn't have covered up. So this is this exterior angle out here with her leg and the ground. Now, if that's the exterior angle, that should be, the exterior, should be absolutely the same as the two remote interiors that are away from it added together. So 2x minus 15 would be equivalent to x plus 50. Do you see what I'm doing there? Exterior equal to the two remote interiors. Now, a little solving, subtract x, add 65, and I'd be able to get the answer for x is 65. And if I wanted the answer for JKL, I could just plug it back in and get the answer for it, okay? Now, let's kind of keep going here and see if we can come up with some other exterior and interior concepts. So find the measures of each of the numbered angles that they want. Angle 2. All right, so we got angle 2 sitting right here. And we're like, what should we do? How much should it end up turning out to be? Well, I think angle 2 is part of a larger triangle right here. See it right there. And we know that triangles should definitely add to 180. 38 plus 90, that's this guy right here, plus angle 2 should add up to 180 degrees. That's pretty much Triangle Sum Theorem like we learned up above. Let's talk about to Donna and see what she says. 180 minus 90 minus 38, and you've got an angle of 52 degrees, okay? 52 degrees right there. Now, remember that there's a 90-degree angle in that spot, too. So if that's a full 90, maybe I should just go 90 minus 52 to get the one that goes in the other spot on the other side. Well, that would be, I think, 38 degrees. Okay, my brain was working there. Woo! Okay, 38 degrees right there. Angle 4, how would I come up with that one? Well, if this one's 90, the guy next door has got to be 90 because it's got to add to 180. And I know that that triangle sum has got to add up to 180. It'll actually turn out that angle 4 will be 52 degrees, which would make this angle over here 38 degrees. Boy, look at that. We got them all. Angle 4, 52. Angle 3, 38. All right? Just systematically break it down in helping you find out what those measurements are going to be. All right? Now, moving over here to the next piece, and look at there, I finished. It would be lesson number 2 is coming up next time. Now, get a big time reminder here, the things that we discussed in lesson 1 was that the exterior angle, that guy on the outside, he adds up to the two guys that are away from him. That's the exterior angle theorem. And last but not least, we also talked about that the triangles always have to add up to 180 degrees. So your triangle sum theorem. All right. Give some homework a shot. These are really not that hard. I think you got it under control. Good luck.